All right, so welcome to 7.2's homework, and there's only two sections in this chapter, which is great for everybody. All right, so let's go ahead and take a look. It says express the confidence interval in the format that uses the less than symbol. All right, so they want it to look like this guy here. All right, it says round the confidence interval limits given that the original times were all rounded to one decimal place. All right, so you see up here where it says t interval, and you see that very first thing right there, that's the confidence interval already given to you. So that's what we need. And we're going to put it right in here. So it says round to two decimal places. Um, Okay, so all you do is take this 85.74 from up here and put it over here to the left. Take this 91.76, put it over here to the right. And that'll be that answer. So I've already answered it, so you know. It's going to be the same for you as well. Part B, identify the best point estimate for the mean and the margin of error. Okay, the point estimate is going to be whatever your mean is. So now it's a little different. It's different from 7.1 where we were dealing with p and p hat, proportions, x divided by n, all that good stuff, right? Now we're just focused on the mean, and you're going to see the mean is our new point estimate. That's our new that's what we're going to be working with from now on in this chapter, in this section. So whenever they ask you for a point estimate, that's going to be your x bar, your mean, 88.5. Now, margin of error is going to be a little bit tricky, but hey, we have a confidence interval, so we can go ahead and use our little trick. As you may recall from the last video, you're going to take your upper, which is 91.76, so 91.76, minus your lower 85.74, hit enter, divide that thing by 2, 3.01, and that's how we get the 3.01 right there. So very straightforward. It's easy for now. Keep those key concepts in, moving forward. All right, let's go. Okay, let's see. Refer to the accompanying data display. Yeah, so this little data display is basically what you get in your calculator. So they solve it for you. So whenever they give it to you, it's a good thing. Choose the correct answer below. And as you can see, yeah, we might as well just go right to it. They want you to get the terminology. Whenever you find a confidence interval, this is the lingo that you want to use. We have 95% confidence at the limits of 13.05, which is this guy here. They round it to the second decimal place, looks like, right? 13.05 megabytes per second and 22.15 megabytes per second is already rounded to two decimal places, so they use the same number. Contain the true value of the mean of the population of blah, 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 blah. So they want you to get accustomed to the terminology because you're going to be making summations, or you're going to be basically summarizing whatever they're saying. So all right, let's go to the next one. Okay, now to the good stuff. Now identify the critical value t alpha over 2 used for finding the margin of error. Now last time we were dealing with z alpha over 2, and remember we use inverse norm. Now we're going to use a different calculator function, and this is called inverse t. So to get to it, you're going to hit second, vars, you're going to go all the way down to where it says inverse t. And they're asking you for the area. Very, very similar to the inverse norm. They want the area to the left, the area that's inside of one of those tails. So you can look in the table, but since we have technology, it's best if you just get accustomed to the technology. And let me show you guys exactly what to put there. So let's exit from here. Let's go to the drawing app for just 1 second. Okay. Histogram. So it doesn't have to be fancy. Go ahead and make your histogram like so. Something like that. Little bell shape. We're going to make two cutoffs for the tails. Just like in the last example from my first video. you want to put your confidence level right here in the middle. Now be careful. 99 is one of those regular confidence intervals. I mean confidence levels that you've seen before, but the answer is not going to be 2.575 because we're dealing with mean, standard deviations. We're going to use a t-score, so it's not quite the same in that regard. But filling out the histogram, the area underneath the histogram should be 1. So remember, whenever you're given a CL, CL is the complement of your alpha. Alpha is the complement of your CL. So remember that alpha is going to be equal to 1 minus your CL. Alpha is the remainder after you do 1 minus the 0.99. So remember, they'll say, what's your T alpha over 2? Let me not put the T just yet. Let's remember, alpha is 1 minus CL, right? Alpha is 1 minus CL. What about when they put this over 2? That means you're going to do the same thing over here. Don't get too worked up on the little formula. Remember, the area underneath the curve should give you 1 whole 100%, right? So just do 1 minus your CL, 1 minus 0.99. You're going to get 0.01 divided by 2. You divide that thing by 2, you're going to get 0.005. That's what's going to go in here, 0.005. And that's what's going to go in here, 0.005. So remember, you want to make sure that when you add all 3 of those, you want to make sure you get your histogram correct by adding them together. So let's just go over here for a second. Take 0.005 in your calculator, plus the 0.99, plus the 0.005 on the right tail, and you should get a 1, and we do. So we know we got our histogram correct. And now what do we do? All you do, very similar to the Z alpha over 2. You're not going to use inverse norm this time, though, because inverse norm, Z is what's normal, right? But this is not normal. We're using T methods. Whenever you're dealing with means of standard deviation, you use T. Whenever you're dealing with proportions and P hat and Q hat, you use Z. Anyway, I know it's a little confusing, but you only have to worry about Z and T. Just those 2 things. Know the distinction, okay? Anyway, the area of what? It's the area in just one of those tails, 0.005. Spoiler alert, the answer is going to be negative, but we know what to do with that. Just take away the negative. Degrees of freedom. The most easiest concept I've ever seen with degrees of freedom is just your sample size. So remember, DF is just equal to your n minus 1. It's 1 less than your sample size. So what is your sample size here? 36. So this is just 36 minus 1, which we know is 35. Keep hitting enter. It's going to be negative. Don't freak out. This is negative 2.72. We want positive. That's what's over here. This cutoff right here is negative 2.72. We came here for the positive version, this guy here, which is positive 2.72. Remember, everything is symmetrical in this histogram, so whatever you get on the left, you're going to get on the right. And this is what we came for. Did I put 7.5? I meant to say 7.2. I know I said 7.2. I don't know what's going on. Anyway, yeah, that's it. Okay. So that's how we get the 2.72 in our answer. So now find the margin of error. Now, instead of using that formula that they gave you, I believe it's T alpha over 2 times the standard deviation divided by the square root of n, right? We don't have to use that. Let's go ahead and find the confidence interval for this. We're going to do the upper minus lower and divide by 2. Like, you can't go wrong. It's almost like it's just like from the last example, but now we're going to use a different function. So remember, we use 1 prop z interval. This time we're going to use t interval. So go to tests. We're going to go all the way here until we see t interval. There it is. Now, are we using data or are we using statistics? Well, we don't have a long list of data. We're going to use stats. We're using stats because they gave us the mean, standard deviation, sample size. That's the actual statistic. Those are the actual statistics, I should say. Let me use proper English. Anyway, what is your mean? What is your point estimate? Point estimate is going to be 3227. So 3227.8 Standard deviation is going to be 686.4. Sample size, what was it? 36? I can't see. Yeah, 36. All right, so we have 36 as our sample size. That confidence level is going to be 99. Go ahead and put 99 or 0.99. It's up to you. They know. The calculator always knows. All right, and we're going to get our confidence interval. Look at that weird looking confidence interval, right? Got some decimals, but it's our confidence interval. We came here for E, so remember that E is going to be, let's write down a formula for E just in case you didn't see the last video, you should watch it. I put a lot of work into that video. All right, sample size, margin of error, E. So remember that E, which is margin of error. So let's say margin of error, I don't know, abbreviation, is going to be equal to your upper minus your lower divided by 2. So your upper here is 3.5. You know what? Let's write that down. We have 2916.2, comma 3539.4. This is your lower. This is your upper. And we're ready to roll. Let's make sure that's a 9. I don't know my hand. It's a 9, okay. All right. All right, so for your E, it's going to be your upper, so 3, that is not a 3, 3539.4 minus 2916.2, hit enter, divide by 2, 311.6. One decimal place, 311.6. Well done. Okay, now it wants our lower and upper. So you see how we already found this. We found this a while ago to get our E, right? This is not the way we're supposed to be doing it, but because we have technology, we're free to do how we choose. The lower, one decimal place, 2916. We already found the interval from a couple steps ago, right? This is going to be 3539.4. Hit enter. Let us rejoice. Nice work. Now this brief statement nonsense. Remember, you have to say one has 99. You have to call back to the level of confidence. They should all have 99s in them. Yeah. You have to say one has, or well, let's get to the bottom of it. That the interval. Yeah, that's it. That's it. So just read that terminology. Let's go back. Yeah, just remember this terminology. One has 99% confidence that the interval for the lower bound and upper bound contains a true. It's always going to look like that. So use your English skills and read it carefully. You should be okay. Anyway, next question. Oh, you guys can't even see the darn thing. Let me go back. At least you'll be watching this as a video. Yeah, that was the answer. One has 99% confidence. Yeah, once again, if you're following along with your homework, if you have your window open in my video, you should be okay. Despite me making a boneheaded move like that. All right, let's see. All right, next. Okay, same routine. We're going to find our E. We're going to write down that confidence interval. Let's go to our trusty calculator and just go straight to T interval. T interval is our best friend in this section. Okay, stats. What is your X bar? What is your mean? Your mean is going to be 0.82412. Standard deviation is going to be 0.00566. Sample size 36. C level, confidence level 95. We're in business. Hit enter again. There's our confidence interval. Now, if you were to type a button here, it's going to wipe everything out. So we're going to go ahead and write it down. Let me go ahead and exit out from this window. We're going to write this thing down. Give me 1 second here. Let's wipe this whole thing out and write down that we have, because you know they're going to ask us to find it anyway. So we have 0.8222, comma 0.82604. I want to stress again, this is the way the calculator gives it to us. This is our lower, and this is your upper, right? Okay, this is our lower and this is our upper. Now we're dealing with means. You know, you can write it this way as well with the two alligator mouths. Remember, these are like teeth, alligator teeth. I don't know. Big kids call these inequalities. I remember them as alligator mouths. Anyway, okay, so you can put the 0.8222, put the 0.82604. It's the same thing, just written a little bit differently, right? Anyway, our E, upper minus lower, divide by 2. So upper 0.82604 minus your lower 0.8222, divide that thing by 2. There is our margin of error, 0.00192. 0.00192. Fantastic. Okay, find the confidence interval estimate. We already got that. Yeah. 5 decimals. Yes, it is 0.82604. Hit enter. We are done. Well done. Brief. One has. Yeah, we want to find out. One has something. One has it's equal. We don't want to ever say that it's equal. That's walking on thin ice. We want to say that it contains the true value. So you don't want to say that solidly like equal to it. And once again, you guys can't even see what I'm doing. Okay, there we go. All right. Here we go. Yeah, we want to say that it actually contains. So next, got it right. What a nice little roll here, right? All right, let's take a look at what we have here. They were nice enough to give us a t distribution table, but you know what? We're not going to use that. I'm not going to say it's useless. This is the way that I started, but technology is just so much cleaner. It saves trees and everything like that. I mean, this is on a computer, but anyway, I don't even think you'll be able to open it up during your test. I'm not sure. I think you can carry one with you anyway. Excuse me. Let's see. What is this? Yeah, we don't need that. Okay. They just want a confidence interval. That's good for us. Straight to the calculator. Calculator is your best friend. And remember, this is compatible with the TI-83. I didn't say this in the last video, but you can use the TI-83 as well. And it gives you the same prompts and everything. All right. So we're going to go over to T intervals. So stats. Move over to test. We're going to go to T. Anyway, T interval. All right, and let's put our new statistics in here. So the mean is going to be 98. So let's hit enter on here, or the down arrow, I should say. So 0.98, it just overwrites everything that you had in there before. Hit enter. Standard deviation 0.74. Hit enter. Sample size, I don't. 110 body temperatures. That's it right here. 110 body temperatures, right? Hit enter. 99%. That's your confidence level. Calculate. And we're good. They want 3 decimal places, so 0.795. I'm not typing anything. 0.795. And we have 1.165. Oh, I did something wrong. It says 3 decimal places. What did I forget? 1.165. Yeah, what did I do? Data sign 98.74. 0.795. Did I do? Let me go back. Stats. We're gonna go to T interval. All right, I put 0.98. It's 98, not 0.98. My bad. All right, 0.7. Yeah, everything is good so far. I promise. All right, this is more like it. This actually makes more sense to the. Yeah, it rarely will ever be a decimal like that, short little decimal. Anyways, 3 decimal places, 815. I'm sure you guys were screaming at me at the screen saying, no, put that, no, you put 0.98, da, 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 da. Yeah, don't worry, everything's fine. Everything is okay. Fantastic. What does this suggest about the use of 98.6 Fahrenheit as the mean body temperature? Well, where is 98.6? Is it within here? It's actually not within this interval, right? 98.6 is somewhere greater than the upper boundary, the upper limit. What does it suggest? What was this whole thing about? Body temperatures, healthy humans, right? This is about healthy humans. Yeah, these would be healthy humans. What does it suggest about the use of 98.6? 98.6 as the mean body temperature, like this portion here. I would not say that because it's not in here. Um, what does this suggest about the use of 98.6? It's hmm. Now our interval is lower, but I'm not gonna lie, I'm good at the math. I always get these wrong, but I got this one right. I'm not no boast, I promise. Anyway, yeah, let's go back to that one. Our interval is smaller than what they're giving us. So this is the real deal. This is the answer that we got. It's smaller than what they're proposing, right? So the mean body temperature is whatever we get, and it has to be lower than this because it is because this is higher than our interval, so our interval is lower than this. We're going to see if I mess up again later. Anyway, all right, clinical trial was conducted, blah, 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 blah. Let's just go ahead and go to T interval, call it a day. Because ain't nobody got time for that. Do people still say that? Oh, I don't know. Showing my age again. Okay, okay, so we're going to need a mean. Let's find our mean. After treatment, 18 subjects had a, so hey, we have our sample size, that's 18. We have our mean, 77.9. 77.9. So you see, I should be reading the whole passage. Reading is fundamental, but I'm just getting what I need and getting out. Standard deviation 24.2, 24.2. We already have the sample size. Confidence level is 95. You could put 95 or you could put 0.95. It's up to you. Let's hit enter, enter. There is our confidence interval. They wanted one decimal place. So 65.9, 65.9. Upper is going to be 89. So 89.9. And that's a fantastic. This crap. What does the result suggest about the mean wait time of 102 minutes before the treatment? All right, 102 minutes is greater than his confidence interval. The confidence interval does not include the 102 because it's not in between 65 and 89, so it doesn't include it. The mean wait time of 102 minutes before the treatment, so the means before and after the treatment are different. I'm hoping. I'm not good at these. This research suggests. I don't know. I'm not sure. I'm not even gonna. Then it's not that one. Memorize that one. Yeah. Just memorize the subject matter. I don't. I'm not too crazy about the subject matter. All I care about is the math. This is really for you guys. I know which answer I'm gonna put. I'm gonna remember what that answer was, and that's what I'm gonna use every time I come across that question. All right, archaeologists have studied sizes of Egyptian skulls. Blah blah blah. They gave us data this time, and that's fine. The data is nice and small, so we don't have to go to StatCrunch or anything like that. We're gonna go to stats. We're gonna go to edit, and we're gonna manually put all of these data sets, put all of these pieces of data in. So 127.7, hit enter. We have 138.3. We have 126.2. We have 131.7. We have 143.1. We have 134.8. Then we have 139.2. 128.7. All right. Make sure you hit second quit because sometimes there's funny business going on. You'll type something and then you're putting in another element to your list. We want to go to stats. tests, t-interval. And look, we're not going to choose statistics this time. We don't have any statistics right now, but we do have data. So select data. Where did that data come from? Remember, the data came from your L1 column. Or you can rewind the video to look. I know it's there. L1 frequency, leave the frequency as 1. It's just one occurrence. Sea level is 90. Go ahead and put your 90 or 0.90. They know. The calculator knows. And we're done. They wanted 2 decimal places, 129.61. The upper is 137.81. Fantastic. Hey, they didn't ask us any questions. That's great. Okay, samples of data are collected and blah, 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 blah. Okay, we already know what we're going to do. Hit stats, edit. Now, if you wanted to clear everything here, you can either go all the way up here. Well, let me show you the safer way. And by safe, I mean that there's a chance that you can delete your L1. You can delete it flat out and you have to manually put it back in. But we'll do this. We'll do clear list. Hit enter on it. And now it's asking us which list do we want to clear. Just hit second. And your L1 is right there in blue on the face of the calculator, like the faceplate. Just hit 1. So remember, you hit second first and then 1 to get the blue, because you hit the blue button to get everything in blue. All right, anyway, hit enter. It is done. Let's go ahead and clear stats, edit. Now everything is clear. Anyway, let's type in our numbers. 1, 1, 2, 3, 4, 3, 4, 3, 3, 2. All right, let's exit to avoid the funny business. Stats, tests. We're going to go to t-interval, and this is a lot of, it's just repetitive at this point. All right, data, L1, yeah, CL, what's our confidence level? 95. I'm going to put 0.95 for kicks, just to show you that you get the same answer as if you were to put 95. All right, there's our lower. 1 decimal place, 1.8. Upper is 3.4. Excellent. What is the practical use of a confidence interval? Right, a confidence interval. This is a good question. The confidence interval can be used to estimate that. Yeah, this is that terminology you want to look for. Actually contains the true whatever. So just put the numbers that you got from the previous step, and that should be it. So 3.4. Hit enter. Uh-oh, I got one wrong. So it's not that? What is the practical use of confidence intervals? Oh, this doesn't measure anything. These are for DNA. These are DNA bases. They have no they have no true value. It's almost like numbers on a jersey. Like they don't really represent anything. It caught me slipping. I'm not gonna lie. It gets so used to that. Yeah. So look at the subject matter. If you're getting a DNA question like this, you want to know whether it makes sense to use a confidence interval or not. Man, I'm sweating. AC is broken. Anyway, next. Okay, same routine. Stats. We have data. Let me go back. Stats, edit. Now I'm going to show you how to clear this. Okay, do not hit the delete button. You hit the delete button, you're going to get rid of your L1. Hit the clear button and hit down. Or you can go back to the clear list thing I showed you a little while ago. All right, anyways, 0.5, 0.82, 0.11, 0.89, 1.37, 0.5, 0.93. Let's hit second quit, stats, tests. You do this a million times, you'll just navigate through your calculator like it's nothing. All right, we're using data. So data L1, what's your sea level? 99. Enter, enter. There it is. 3 decimals. I hope you guys tell your friends who are struggling in stats, or even if they're not struggling, if they're planning on taking stats, please have them subscribe to my channel. I'm up and coming. I'm a little rough around the edges right now. I just started my channel not too long ago, but you're gonna learn something. You're gonna pass your class if you stick with this channel. I guarantee it. Anyway, does it appear that there is too much mercury in tuna sushi? Yeah. Okay. So they're talking about mercury. Apparently, I didn't even read. Okay. Food safety guideline is that mercury in fish should be below 1 part per million. Listed below are amounts of mercury found in tuna sushi. Okay, so let's see, amounts of mercury. So this is the amount of mercury in parts per million. All right. Does it appear there's too much mercury in? I would think, yeah. That what is considered too much mercury? I think any amount of mercury is too much mercury. 1.2 parts per million. I'm not sure what parts per million is. I'm not sure what's the perspective on that. All right. Let's see. Yeah, it is possible it could be greater than 1 because 1 is within this interval. We actually, our upper limit is 1.2, so yeah, it could be greater than 1. I'm gonna choose that. I'm gonna choose that. Don't want mercury in my food. Anyway, next, sample size. Now we have a different sample size this time, and believe it or not, it's a lot easier than what we experienced with the Z method stuff, where we had to have a p hat, and if we don't know the p hat, we put 0.25 and blah 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 blah. But it's a shorter formula. Let's leave here. I'll try to remember to turn that back on so you guys can see the question. Let's go ahead and clear this stuff here. Here's the formula. Ready? This is when you're dealing with means and standard deviations. Okay. So the sample size now is going to be your Z alpha over 2 times your standard deviation divided by your margin of error, and the whole enchilada, the whole thing is going to be risen to the second power. And it's always going to be like this no matter what. So how do we, and we're not using Z alpha over 2, I don't think. Because hold on, we are using Z alpha over 2 because we have the standard deviation, the population standard deviation. We're soon gonna find out. Anyway, we have a 99% confidence of. Oh yeah, let's go ahead and write that down. 99% is one of those special percentages. So over here we have CL. Over here we have Z alpha over 2. I know we were using T a little while ago. Remember, T is when you use T when you don't know your population standard deviation. You use Z when you do know it. So let's write this down. We're using Z without a doubt. So this is 0.90. This is going to be 0.95. Remember, these are your 3 basic ones. It'll be nice if you memorize them. That'll be 1.645. But, it's on your Z-score table too. Like, you'll see it's probably at the bottom left or the bottom right. I can't remember. 1.96. And this is 2.575. Remember, you can always use the calculator to get those as well. And just for a little refresher, like for example, we're using 99%, right? We know that's going to be 2.575. So remember, make a little fancy histogram like this. Put your CL in the middle, 0.99. You do 1 minus 0.99 to get the remainder. You get 0.01. This is your alpha. Now it's in 2 different parts. It's in 2 different tails. So you divide that thing by 2, and you're gonna get 0.005. That's what goes here. That's what goes here. Remember, our trick is to take the inverse norm of that. So inverse norm, we're gonna put 0.005. This is the Z-score, so the mean is 0, standard deviation is 1. Hit enter, and there we go. We have the negative version of what we're looking for. Even if you mess up and put negative 2.575 in here. When you square that, it's going to change it to a positive. So remember that from college algebra or whichever class you took before this or during this. Uh, anyway, we already have 2.575 here, so there's no need to go to your calculator. If you ever get 90%, 95%, 99% for your confidence level, you can have the three values waiting for you right there. So it should be in a table. If not, just write them down till you memorize them. They're not really that hard to memorize. Anyway, where were we? Yeah, so we're looking to find the sample size for here. And you know what? We're going to just use the calculator for this one. So let's go ahead and hit clear. We're going to hit second alpha y equals. Okay, so what we're going to put in here? We're going to put z alpha over 2. You know what? Let's go over here to put everything in parentheses, nice and neat. What goes on top? We have z alpha over 2. We're using 99%, so that's going to be 2.575 times your standard deviation, your population standard deviation is going to be, where is it? I just saw the thing. 10. It's right there in the passage, right? So 10. On the bottom, we have our margin of error. It says within 6 IQ points. Whenever you use that terminology within something, that's going to be your margin of error, your E. And if you recall from the last video for 7.1, they kept saying percentage points. Whenever you're dealing with proportions, you're going to have percentage points. But they didn't use the word percentage here, did they? So you're not going to change that into 0.06 like we did before. This is just a 6. So no funny business here, okay? All right, we're going to square that whole thing, hit enter. There's your sample size. Now, I believe it's going to use the same rules for the rounding, and we always just go up 19. We're going to find out. Yep, so it looks like they're using the same rules. We'll see how long that lasts. Whatever you get, just add 1 to it. You're done. I did say I was going to remember to bring it back up. Here it is, as you can see. Okay, would it be reasonable to sample this number of students? I would say no. 19 is not very large to me. Once again, we're gonna find out. I would say it's a fairly small number, and I'm gonna say no. It's not enough people. You answer no. The correct answer is yes, because the number of tests. What? Just commit that part to memory, okay? Anyways, I always get those wrong. You're gonna see that's a recurring theme in these. But I can get an A on this test if I just remember that stuff. Hopefully you can get one too. We're already at 81.82. We're on a roll. I did do some of these already. Anyway, find the sample size needed, blah, 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 blah. Okay, 95%. Okay, we're good. We're going to use the formula again. Let me get my fraction ready. Okay, so what do they want from us? Z alpha over 2, 95. That's going to be 1.96. And don't worry, we're going to raise everything to the second power when we're done. So you don't have to put everything in the parentheses right now. You can wait till the end. Hit enter, then wait till the end. Anyway, standard deviation. Population standard deviation is 19.3 divided by your E, your margin of error. It says within 1.5. That's margin of error language. Let's hit enter. Let's take our answer and raise it to the second power. Enter again. Excuse me. We're going to say this is 636, no matter what is to the right of that decimal. Normally, when it's 5 or more, we add 1 to it. When it's less than 5, we keep it the same, right? But with sample size, you cannot have a fraction of a person. You can't have a decimal of a person. If that's 0.76, if you get 0.76, for example, you always just go up. If you get 0.000001, like 103.0000001, that's 104 automatically. So you always add 1 to it. I hope they stay consistent with that. Anyway, 636. Okay, could the sample be obtained from one movie at one theater? All right, so I didn't even, once again, I didn't even read the subject matter. Find the sample size needed to estimate the mean age of movie patrons such that it's said to be 95% confidence that the sample mean is within 1.5 years. All right, so this is ages of people watching this movie, I guess. Or watching movies, not just one movie. Could the sample be obtained from one movie at one thing? I hate these. I'm good at the math. Math is my. I'm not true. I'm not. I don't analyze that well. But you see, we've been getting it right with the 50-50 stuff. Right. Anyway, the sample. Let's try to get this one right. The sample should not be obtained from one because the sample could be easily biased. Instead, simple and broader population should be. The sample should be obtained from one movie at one theater. Nah, we're not going to say that. One is not enough. All right, the sample should not be obtained from one movie at one theater because the sample could be easily biased. Instead, a cluster sample. The sample should be. The sample should not be obtained from one movie. I. We're gonna see. Yeah, 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 yeah. Stick with this. Read it. Give you a second. Go ahead and read it. Stick with that. It just spoke to me. I don't know. All right. Yeah. What's the probability of me getting these questions right off a whim? Anyway, all right. The pulse rates. I have a little understanding of this stuff. I know the language that they're. I know what they're trying to get at. That's the reason why I lean towards the correct answer most of the time. All right. Not tooting my horn at least. Trust me. At the very least, I'm not tooting my horn. Anyway. Another sample size. Let's do it. Second alpha y equals, let's say enter to get your fraction. Okay. Once again, 98. Damn. Okay, so they're not using one of the they're not using one of the three nice confidence levels, 90, 95, and 99. And I expect that on your exam, on the exam, is gonna they're gonna give you an oddball, like a curveball or something. So listen, it's okay. We're gonna handle business. I promise. So they're using 98%, right? So you know what? We're gonna make a fancy histogram. Let's go ahead and delete all this stuff here. Okay, so fancy histogram, like so. And we're just gonna find one of those tails. As soon as we have one of those tails of the histogram, we're gonna hit inverse norm. Oh, are we allowed to use inverse norm? Do we have a population standard deviation? Find the minimal sample size. Let me let you guys see. Find the minimal sample size recorded to estimate the mean pulse. Assume 98. There's our E. Population. They didn't give us a standard deviation. Am I blind? Oh, range rule of thumb. I'm not familiar with the range rule of thumb. Let's look at an example. Let's see what they use. Okay, range rule of thumb. They find the range and they divide by 4. Okay, I'll take it. And they use that for the standard deviation. Okay, I guess. All right, we'll do the same. So the higher one here is 121. The lower is 41. I guess. Okay, so 98%. Oh yeah, so they're going all out with this one. Okay, let's go back to making the histogram. We'll get back to that in a second. There's a lot to unpack here. Anyway, let's go back to my board. 0.98. Let's figure out what the missing thing is. So the missing things are actually. they're going to be the same. So you do 1 minus 0.98, which will give you 0.02. Divide that sucker by 2, you get 0.01. That goes here. That goes here. I know I did it fast. Let's make sure that we add these up. If you do 0.01 plus 0.98 plus 0.01. Yeah, I know we only need 1 plus, but it's okay. That's a 10 carry to 1. 0. Yeah, 1.00. That's 100%. We're going to take the inverse norm of just one of those tails. So let's go back to our calculator. So let's clear this mess. Inverse norm, just one of those tails. We got 0.01. So 0.01. Hit enter, 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 enter. Negative 2.33, which means that we're going to use positive 2.33. So we got this guy, but we came here for this guy. Fail. All right, and this is z alpha over 2. And we're good. Remember, this is negative z alpha over 2. They're both the same number. It's just that one is a negative, one is a positive, but we want to use the positive version. Did I really just put another negative right there? No, that's positive. 2.33. Positive. Anyway. Okay, so in our calculator, we're going to go ahead. Second alpha. Bam, bam. Go ahead and put your 2.33 times. Now, that weird range rule of thumb, let's hit clear. We're going to have to figure out what that is and then hit enter, then write it down or something, or commit it to memory. We do the range rule of thumb, which is going to call for us to do 121 minus 41. This is all because we don't have a population standard deviation. We're going to divide the sucker by 4 and we get 20. That's the standard deviation that we're going to use because they didn't give us one, but it's all good. So I'm going to go back up to the fraction. Oh, we don't have a fraction. It's okay. We're using 20. Okay, so bear with me. Here's our fraction. We're going to use 2.33 times 20 divided by the margin of error. It says within 4 BPM. So divided by 4. Let me let you guys see that. All right. Don't forget to raise everything to the second power. 136. Sheesh. Nice work. Okay, now they gave us a standard deviation to use. We're going to go right back up here. We're going to go to the 20. Delete, delete. Okay, and we're going to put our standard deviation in 12.22. I mean 12.2. What am I saying? All right. 7. That means we're going to change that into an 8. I forgot to square it. It's going to be like 49-ish or 50 or something like that. Anyway, hit this. I'm going to hit square. 50. They one higher, 51. Okay, compare the results from A and B. A is definitely larger than B when we do the point estimate stuff, the range rule of thumb stuff. Compare the results from A and B. Which result is likely better? The one that gives us a higher sample size is usually the better one. Let's see. The result from part A is definitely larger than that one. The result from part B is likely better. Part A is likely better because it uses better as. I don't know. We got that part right, so this is part B. I'm so lame. Anyway, we got it. We got it. We got it. Just commit that to memory. How many more questions we have left? We have 2 more left. It's been great, but I'm not gonna do this again for a while. All right. Let's see. They gave us the range rule of thumb this time. All right, that's nice. Let's see. 99%. So 2.575 times standard deviation. They used the range rule of thumb again. They did it for us. 1.25. Gonna divide by the E, the margin of error. Did he give us any E? Let's see. Assume blah, 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 blah. How many scale between 0 and 5? How many grade point averages must be obtained? Blah, 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 blah. That between 0 and 5. I wonder if it's actually 5. Let's go to view an example and see if they're giving us the margin of error in that form. Identify the population standard deviation in the design. Okay, this is 0.017. Where'd they get that from? Oh, wait. It's here. Ha! It was just hiding in there. 0.011. Got ahead of myself. Bam. Let's go ahead and hit square. Bam. That's a lot of people. Nearest whole number is 85623. Well done. Does this sample size seem practical? They're talking about grade point averages. I would say no. This is a very large number. That's a Yeah, good job. Something about All right, anyway. This is the last one. It's been great, guys and gals. Let's see, we refer to the accompanying data set. All right, so we have a data set here. Let's see. Okay, construct the 95% confidence interval of the mean pulse rate for adult females. We have a whole data set here. And we have females over here to 82, 95. They don't care about the males this time. So, you know what? We're going to use StatCrunch because that's way too much data to be putting inside of our calculator. And whenever you see so much data like that, don't use your TID for. They're not going to put something like this on the exam. I think it's safe to say. Whenever they have to give you a link for StatCrunch, you're not going to have to do that. I might have to exit out for a second. I don't think it's going to pick up the StatCrunch window, but let's see. I think I can make it happen. Okay, let me see if I can find the StatCrunch window. I never did this in the middle of a... Yeah, looks like I got it. Nailed it. Okay, so we're only focused on the females, right? So you remember the statistics that we need? We need the mean, standard deviation, and we're golden. So to find the mean and standard deviation in StatCrunch, you go to Stat. I believe we can go to ZStat or TStat. It doesn't matter which. Let's do one sample with data. We're going to choose females. And don't worry about all that other stuff. Let's just hit compute. We came here for the mean and standard deviation. They didn't give us standard deviation, darn it. They just gave us the mean, 75. I forgot how to find the standard deviation. I remember the standard error is 2.1. My brain is going off right now. If we can... We'll write down the mean, 75.8. So we'll go back to here. Let's write down 75.8. Okay, yeah, let's write that down. Let's start by wiping all of that out. Let's write mean is equal to 75. 75.8. And we need our standard deviation. I remember, if I can recall, the margin of error is equal to your z alpha over 2 times the standard deviation divided by the square root of n. Funny thing is that this piece right here is called the standard error. Just the portion in the parentheses. So if we're going to get the standard deviation out of that, we're going to set up a little algebra. I hope they don't make you guys do this. No, they're not going to make you do it because it came from StatCrunch. I hope I get this right. This is a true test of my mathematics. Okay, so standard error is equal to the standard deviation divided by the square root of n. They want you to find the standard deviation. So we have to multiply both sides by the square root of n. So multiply by the square root of n. That cancels. So the standard deviation is equal to the square root of your sample size times whatever the standard error is. Why couldn't it just give us the standard deviation? I have no idea. This should work, I believe. The standard error, by the way, let's go up here now. I can extend this down a little bit. The standard error, so the standard deviation, let me make sure you guys can even see this. Yeah, you can still see. All right, standard deviation is equal to the square root of your sample size. How many is that? Sample size, they didn't give us a sample. They just wiped everything out. Are you kidding me? All right, I gotta do it again. I can't believe that. They just wiped it out completely. Okay, here we go again. I guess I better write it down quickly this time. Oh, I know why. I keep clicking on the damn thing. Careful, Dan. Okay. We're gonna go to stats, t-stats, one sample with data, females, hit compute, standard error 2.1537683. Let me just very carefully sample size. I'm going to get the sample size in a minute, but let's write down standard error 2.1537683. Now we're going to go ahead. We don't need StatCrunch anymore. We're going to go ahead and count all of these numbers of females. So 1, 2, 3. Did they tell us at least? They never told us how many females it is. That's nice, but it's okay. We're just going to go ahead and count these one by one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That's another 20. That's 40. That's going to be 40 as our sample size. Let's go ahead and write that in here. Well, I promise you people, life should never be this hard with stats. I know math is already hard as it is, but it should never be this tough. This is ridiculous. Anyway, I'm praying that we get it right. So square root of 40 times 2.1537683. I'm proposing that that's my standard deviation. So I'm going to write my standard deviation as 13.6216. That should be fine. Okay, we have our mean. We have our standard deviation down here. Took forever, but we got it. We're going to go ahead and use our calculator at TI-84. Or TI-83 is up to you. They do the same thing at this point. Stats. We're going to, you know what? Since I just got this answer here, I didn't even have to write it down, but it's best to write it down, as a good practice. Stats, we're going to go over to T interval. We're going to go over to stats. So if we would have put all these 40 of these pieces of data in, we would have gotten the answer. But it's just so tedious. It would have been easier if we would have done that in hindsight. But anyway, I digress. Okay, the mean. Let me just close this for 1 second. The mean is going to be 75.8. Standard deviation is 13.6216. Sample size is 40. Confidence level is going to be 95. So let's go ahead and hit 95. Enter. I hope this is right. 1 decimal, 71.444. So 71.4. 71.4 and 80.2. And I am the math god. You hear me? Do you understand what I'm saying? I am the math whiz. I'm the best. I'm awesome. I'm the best tutor/student ever. Give me my props. Subscribe to my channel for that epic win right there. Handle business. Come a long way. Oh, I spoke too soon. I construct the 95% confidence. For adult male, it's the same thing with the adult males. Do you guys really want to? At this point, you can shut the video off. I'm gonna do it because I'm a little OCD when it comes to math. I gotta complete everything. Man. But you know what? I'm not gonna. I'm just gonna put the data in. I don't have time for all that math. that's ridiculous. This is good. You know they're gonna ask us some off the wall question about, oh, what does the data suggest about the blah 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 blah. You know, we're gonna be prepared. Anyway, I'm gonna put all these pieces of data in here because it's easier. Even though it's tedious, it's easier. Like if you have a bunch of $1 bills on the floor, like it's like a million $1 bills, it's not hard to do. 1, 2, 3, 4, but it's just tedious. You know what I mean? We're gonna go ahead and put everything here. 85, 76. Or you can use Microsoft Excel, but I don't. I'm gonna use Excel. I'm using Excel. I am using Excel. Okay, so to use Excel, we hit here, we go to open in Excel. And let's see, is it opening? Oh, it's down here. It's downloaded. Okay, so let me activate Excel for you guys. Let's go to window capture. We're going to go to Excel this time. Bam, there it is. Okay, so Excel, let's see if my skills are still on point. We're doing this for the males. We want the mean and standard deviation. So I'm going to go here. I'm going to hit the equal sign. Let me make this a little bit larger for you guys. I can't. Anyway. So lame. Okay, I think it should be larger for you guys now, right? Yeah, it is. Okay. Isn't this just so fun? Oodles of fun. Anyway, we have to find the standard deviation formula. Let's see if I can remember. I don't really do Excel like that. Formulas, insert function. We want to find standard deviation and mean. So how about we find mean? Oh, they don't use the word mean. They use the word average. Tomato, tomato. And what do you want to take the average of? All the males. Enter. They gave it to us 67.325. They gave it to us right there. This is for mean. We'll just type that in like good little mathematicians and good little Excel users. We're going to do it again, but this time we're going to pray that we can find a standard deviation function. So standard guess this is it. Oh, no, I guess not. All right, let's look for a regular looking standard deviation function. There it is. stdev. It's pretty basic. 12.32, we'll just put it here. Bam. That's a lot simpler. Why didn't we just use Excel the first time? Okay, so look. We're golden, okay? We have everything we need. Let's go ahead and take off this window capture. I can see it, don't worry. Or I'll let you guys see it as well. Okay, calculator. We're gonna go over to stats, test. We're gonna wait. I'm jumping the gun. What was the goal here? What are we doing? I'm just gonna let me just make sure I remember what we were doing. Oh, we're finding yeah, okay, we're on the right track. Don't worry. Let me put that window back up so you guys can see the mean and standard deviation that we fought so hard to get. All right, this is T interval. The mean that we're going to use is 67.325. Let me double check. 67, yep. And then 12.32. 12, I'm going to put 12.33 just for the heck of it. For standard deviation. 12.33. 40 again. 95. Did we use 95? Yes, they did. All right. Enter. Let's get out of this window capture so you can see what I'm putting. Using this video editor as an art, I tell you what. Okay, 63.38. 1 decimal place. 0.4. 71.3, and you got all the swag in the world. I wasn't confident. Okay, compare the results. You already knew it was coming. Looks like the women are a lot higher than the men. Let's see if that means anything. The confidence intervals do not overlap. Let's see if they overlap. This is from 71 to 80. This is from 63 to 71.3. They don't overlap. This part right here, right to where that last part ends is where this one begins, right? So they don't overlap. So they do not overlap. Let's see. So look, I don't know. All I know is that they don't overlap. Okay, and I got it right again. I never get those wrong. That's it. 100%. If you made it this far, thank you so much for watching. This was quite the journey. Took a few hours of me doing this. If you enjoyed this, if you get an A on this next exam, please let me know. And please give me more subscribers. Leave a like on this video. Comments, concerns, questions, send them my way. Thank you so much for watching.